Get ready to redefine your ideas about black holes, because what was thought to be known about them may be just the tip of the iceberg. Recent findings, including discoveries by Russian scientists, are shaking up our conceptions of these mysterious cosmic objects. The traditional idea that black holes are simply skylights to other dimensions is being challenged. The reality is far more intriguing and frightening. According to NASA studies, black holes are entities in space with such an immense gravitational pull that even light cannot escape from them. This was initially considered impossible until in 1915, Carl Schwarz found the solution to Einstein's equation predicting their existence. The discovery of the black hole Cygnus X1 in 1964 revolutionized astronomy by turning a theory into a physical reality. This black hole, 15 times more massive than our Sun, is part of a binary system with a companion star, making it a powerful source of X-rays and a crucial proof of the existence of these phenomena. Although Cygnus X1 is about 7,000 light-years away, it has been discovered that there are more than 100 million black holes within our own galaxy, the Milky Way. These entities, invisible and enormously larger than our Sun, represent a terrifying phenomenon in the cosmos. Scientists have explored two main paths to understand how these black holes form: from collapsed stellar bodies and through the direct collapse of gas clouds under their own gravity. In both cases, these cosmic objects arise from the intense gravitational pull that dominates outer space, where the absence of gravity and air allows such phenomena to occur unimpeded. The cosmic cycle begins with stellar evolution, where the initial stars, with a mass between 8 and 10 times that of the Sun, are the protagonists of a fundamental process. These stars, by fusing hydrogen into helium in their cores, go through their stage of brilliance until they eventually exhaust their nuclear energy. This depletion leads to a catastrophic event known as a supernova, during which the outer layers of the star violently break away into outer space, in a silent spectacle since sound cannot propagate in the vacuum. Supernovae can give rise to one of the three things: a neutron star, a white dwarf, or, if the star is massive enough, a black hole. Surprisingly, a supernova at a distance of 65 light-years could have devastating consequences for the Earth, significantly affecting the ozone layer and endangering life as we know it. As for the second pathway, the direct collapse of massive gas clouds, this process skips certain stages of star formation and can occur in regions of space where the density of gas and dust is high. Here, gravitational forces can cause the clouds to collapse, directly forming a protostar in some cases, while in others, the collapse is so intense that a protostar does not even form and a black hole emerges directly. It is often questioned how long these black holes persist. They are believed to be eternal entities once formed, with a lifetime potentially in the billions or even trillions of years. Their gravitational pull influences the structure of the universe, attracting dust, gas, and even stars to them. The presence of a black hole manifests itself through its influence on surrounding objects, such as stars and gas, generating an emission of high-energy radiation, such as X-rays and gamma rays, reminiscent of the Death Star. Stephen Hawking in the 1970s contributed to a theory that postulates that black holes emit radiation over time, known as Hawking radiation, which eventually causes them to fade away. This Hawking radiation originates from fluctuations near the black hole's event horizon, where pairs of particles spontaneously appear out of nowhere, including their opposites, the antiparticles. It is an intriguing phenomenon that illustrates the unpredictable and dynamic nature of the cosmos we inhabit. When a pair of particles appear near the event horizon of a black hole, something peculiar happens. They annihilate each other and disappear forever, in a process as rapid as unpredictable as their initial appearance. On certain occasions, one member of the pair may fall into the black hole while the other escapes into outer space, defying the enormous gravitational forces at play. The particle trapped inside the black hole experiences a partial loss of energy from the surrounding vacuum. This stored energy adds to the mass of the black hole, resulting in an emission of radiation known as Hawking radiation. This radiation is not only characteristic of black holes but also helps scientists discern between them and wormholes, two cosmic entities that, despite certain similarities, differ in the nature and behavior. Wormholes are hypothetical tunnels in space-time that connect two distant points. Although this concept may sound like something out of science fiction, scientists have been investigating their possible existence since the time of Albert Einstein and his theory of general relativity, published in 1915. According to this theory, the curvature of space-time caused by the presence of massive objects, such as planets or stars, could allow the existence of such structures. The future of space exploration depends largely on technological progress. We have already developed telescopes capable of observing past events in the universe, such as the James Webb Telescope, which has made amazing discoveries. The ability to capture an image of a wormhole would be a monumental milestone in astronomy, revolutionizing our understanding of the cosmos. So far, however, research on wormholes has been limited, but other recent findings have astounded the scientific community. Before going into detail, it's important to review some of the black holes we have already discovered. One of the most notable is Messier 87, also known as M87, a supergiant elliptical galaxy located 55 million light-years from Earth in the constellation Virgo. M87 has been an object of fascination since it was first observed by Charles Messier in 1781. The galaxy contains trillions of stars, and its core emits powerful radio waves. Its black hole, called M87, is especially remarkable, with an unimaginable size and mass. In 2019, the Event Horizon Telescope captured the first image of this black hole, marking a history milestone in science and confirming the predictions of Albert Einstein's theory of relativity. The image revealed the silhouette of the black hole, providing direct evidence for the existence of supermassive black holes. This discovery also suggests the possibility that the wormholes predicted by Albert Einstein's theory are a reality. The influence of the black hole M87 on its host galaxy is striking, acting as a massive gravitational center that affects the surrounding stars. This raises the intriguing possibility that the universe itself functions as a gigantic system, with black holes playing a crucial role. Furthermore, the existence of such massive black hole suggests the possibility that there are even larger black holes, exerting influence on other black holes in the universe. The future of space exploration is full of promise and mysteries to be discovered. The idea of a universe even more vast and complex than we imagine is both exciting and terrifying, challenging our understanding of cosmic reality. Black holes are one of the most fascinating and mysterious phenomena in the universe. They are enormous entities with a mass between 2 and 4 million times that of the Sun, but at the same time practically invisible to us. Until recently, we knew very little about them, but thanks to the research over the last 2 decades, we have learned more and more about these enigmatic objects. Recently, Michio Kaku announced a momentous discovery. We have managed to find out what lies inside a black hole. This new information has illuminated details that might have gone unnoticed in the scientific world. We have delved into black holes and revealed the secrets of these mysterious spaces. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Although many of us have a general idea of what black holes are, there are still some gaps in our knowledge. In 1916, Albert Einstein published his theory of relativity, which predicted the existence of black holes. At that time, the concept of black holes was purely theoretical. It was necessary to wait another 50 years for the scientific community to find evidence of their existence. In fact, this event occurred in the 1960s when scientists were studying the constellation Cygnus. During their observations, they noticed a bright blue star emitting X-rays. They discovered that these X-rays were not moving on their own, but were attracted to a giant black object around which the star was orbiting. This is how the term black hole was coined. This discovery was significant because it provided concrete evidence for the existence of black holes, demonstrating that they were not merely fragments of Albert Einstein's imagination. It also revealed the existence of an incredible entity in space that we urgently needed to investigate. This black hole was named Cygnus X1 and is located in the constellation Cygnus, at a distance of approximately 6,000 light-years from Earth. This was no small discovery, as it had an incredibly high density, which gave it a strong gravity. Scientists undertook the search for other black holes and discovered that there could be around 100 million of them in our own galaxy, the Milky Way. However, due to their extreme difficulty in detection, we still do not have a precise number. It appears that there are several million black holes in our galaxy, which makes them very important objects of study. The main concern with black holes has always been their gravitational attraction so intense that anything that enters them will be astronomically compressed into a singularity. Black holes act like cosmic vacuum cleaners, sucking in everything in their path. One of the most disturbing parts of black holes research is the fact that if someone were to fall into one, they would be stretched to the point of becoming a single line. This process would occur slowly and the person would die before the final form is established. Therefore, it is safe to say that no one should venture into a black hole. However, since these objects are present everywhere, questions and concerns arise as to whether we are really in danger. Even though the closest black hole to Earth is 1,500 light-years away, which is still close enough to raise questions and concern. In 2021, scientists managed to publish the first clear image of a black hole, specifically of the black hole M87. For several consecutive nights, photographs of the black hole were taken, and with each image, researchers collected more evidence about it. It was necessary to combine the individual photographs to obtain a complete image that filled in all the gaps. In this way, the scientists discovered that black holes are not just simply an empty hole in the void, as many people believed. In reality, they are much more complex. To reach the empty part of a black hole, 3 previous layers must be traversed. The first layer is known as the event horizon, which is the point of no return. Once the event horizon is crossed, there is no turning back. The second layer is the photonic sphere, which is the region where light orbits around the black hole. Any light entering this region will be trapped and will not be able to escape the gravitational pull of the black hole. Finally, the third layer is the singularity. This is where everything that enters the black hole is astronomically compressed into a point of infinite density. The singularity is a point in space-time where the laws of physics as we know them break down. You're probably wondering what lies beyond the third layer called the singularity, right? The idea is that instead of being crushed by falling into a black hole, one would be sucked through a tunnel through the ring of fire and emerge through a white hole somewhere else in a parallel universe. This tunnel is known as the Einstein-Rose Bridge, or wormhole. This theoretical bridge is a passage through space-time that connects 2 separate regions of the universe or even 2 parallel universes. To understand how this works, we must understand the concept of space-time in Einstein's theory. According to this theory, space and time are not separate entities, but are connected, forming a 4-dimensional fabric known as space-time. Objects with mass warp space-time, creating a gravitational field that affects the motion of other objects. To visualize this, we can imagine a sheet of paper representing space-time. If we place 2 points onto the paper and draw a line between them, we are representing how objects move through space-time. Now, let's consider folding the paper in half and creating a shortcut between those 2 points. This basic idea is what is known as a wormhole. It is a shortcut or connection through space-time that joins 2 distant points in the universe. Although wormholes sound like science fiction concepts, they are actually a prediction of the theory of general relativity. So far, however, none have been directly observed. The reason for this is that wormholes are inherently unstable and would collapse almost instantaneously. However, if a stable Einstein-Rosse bridge existed, it would mean that black holes are not only cosmic devourers, but also portals that could connect us to other regions of space-time. The question then arises whether we could use a wormhole to travel through space and time. Although this is still the subject of speculation and its feasibility has not yet been demonstrated, the theoretical possibility of wormholes opens the door to exploring fascinating concepts about interstellar travel and the connection between different parts of the universe. Imposing masses of enigma float in vast space, a subject that has always left us with unanswered questions. However, the time has finally come for a radical change. The James Webb Telescope shows us what lies inside these towering masses of enigma, also known as black holes. Join us to the far reaches of this black hole to learn more about what's inside. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it so it reaches more people, and turn on the notification bell. It all started in 1916 with Albert Einstein's general theory of relativity, who was the first to predict the existence of these entities. Although the term black hole was officially coined 50 years later, some scientists already believed in Einstein's theory, while others dismissed it. It was in the late 1960s when researchers were studying the constellation Cygnus X1 that they noticed something amazing. A strange bright blue star was emitting X-rays, revealing that it was no ordinary star. This blue star was orbiting around something giant and dark. Upon further investigation, it was discovered that the X-rays were not moving on their own, but were attracted to the mysterious entity that the star was orbiting. Whatever was at the center of that orbit turned out to be a powerful force that consumed everything around it. At that point, science gained official evidence that black holes were a reality, but little did they know that things were about to get even more extraordinary. The initial discovery of Cygnus X1 turned into a series of additional discoveries before it was discovered that there could be approximately 100 million black holes in our Milky Way galaxy alone. However, due to their incredible difficulty to be detected, we still do not have an accurate, precise number. According to current estimates, this number is in the several millions, which makes them even more important objects of study. According to most physicists around the world, a black hole is an entity where anything that enters it is compressed astronomically until it becomes a singularity. To simplify it into simpler words, they have explained that due to the way black holes work, if someone were to fall into one, they would stretch like spaghetti, slowly dying in this form before reaching the final spaghetti form. This is one of the scariest parts of the research done on black holes, and is also what makes everyone want to know all the details. Although the closest black hole to Earth is 1,500 light years away, this information still raises the questions of whether black holes can actually swallow the Earth's whole. In 2021, scientists managed to publish the first clear photograph of a black hole, specifically the black hole M87. The black hole was photographed for several nights in a row, and with each image, researchers collected more and more evidence about it. revealing the existence of three fundamental layers in its structure. That's right, a black hole is not just a lone hole in the void. To delve into the depths of its mystery, you need to understand the first two layers. Let's break it down. First, there is the outer event horizon, a boundary that surrounds the mouth of every black hole. Once something reaches this point of the black hole, it cannot escape and is either trapped there or pulled deeper in its journey into the singularity. The singularity, on the other hand, is the central core of the black hole, where gravity is so intense and constant that literally nothing can get out of there. To escape, something will have to travel at a speed of much faster than the speed of light, which has so far proven impossible. It is important to note that gravity on Earth works differently. If it were similar to the gravity of the black hole, we would not be able to survive the way we do once we have crossed the event horizon. We have in front of us the black holes, the great supreme enigma, the singularity. This is the point at which most of the black hole's mass is concentrated, where everything is compressed into practically nothing. Physics, as we know it, stops working inside black holes, both on Earth and in most of the space we have explored. It is absolute chaos, and the worst part is that each black hole is unique, with a different gravitational force and attraction. You could gain complete knowledge about one black hole only to have to start from scratch when you explore another. It is like a never-ending puzzle. The problem lies in the fact that scientists cannot study black holes in the same way they study stars or other planets. They can't just look at the radiation they emit, along with the dust and gas that surrounds them. They cannot send something like the Voyager probe into the interior of a black hole, since as we have previously established, nothing, it will be crushed in when it reaches the singularity. Simply put, our only option is to study these massive powerful phenomena in space in 2 dimensions, since we cannot get close to them. The fact is that so far we have not been able to get inside the singularity to really find out what it is, because as we have established, it's practically impossible to travel faster than the speed of light. However, this does not mean that scientists who have been studying these giant masses of mystery do not have their own theories. They have numerous theories about what could be inside a black hole other than the singularity. One of the most plausible theories is that black holes are not simply masses of nothingness, but that beyond the event horizons and the beginning of the singularity, there could be something else. This theory suggests that black holes could be like doors, but don't mean a door leading to a common place. We are talking about the possibility of traveling between galaxies and universes through them. Another interesting theory posits that black holes could be a glitch in the matrix, using this metaphorical reference. If we could develop technology capable of faster than light travel, we could open our way through one of these black holes and explore what lies on the other side. However, these theories are still in the realm of speculation, and scientific exploration continues in research of more concrete answer. It is possible that the singularity is not simply a void, but a wormhole leading to another galaxy. It would be a shortcut in stellar travel, something we never thought possible. This idea raises the possibility that we might not be limited to exploring only the planets in our own solar system. We could look for ways to traverse these black holes and reach the galaxies they take us to. If this turns out to be true, it would mean that limitations once assumed to be unsurmountable might not be as impossible as previously thought. At the opposite end of the spectrum of theories, we find one that rejects the existence of black holes altogether. Tokyo-based scientist Enrico Rinaldi and his team have been trying to make sense of these phenomena, despite how strange they seem. They have come up with a simple theory that explains all this madness. According to this theory, black holes are simply holograms. Now, holograms, as we know them, are holographic images created through technology. But here, not holograms are the same. Any visual discrepancy or illusion can be considered a hologram as well. And when we're talking about the vast abyss of space, anything is possible. What do you think? Let us know in the comments box. If you liked the video, remember to hit the like button and subscribe to the channel, and I'll see you in the next one.